Imagine a maze. It has walls and paths. The goal is to find the way through. This is our base maze, a simple puzzle. This maze is small, it's easy to solve, but what if we could make it more interesting? What if we could make it grow? Fractal mazes are special. They start simple, but they can become very complex. They show us how amazing patterns can come from simple rules. Let's explore how these mazes are made, starting with our basic design. Now let's look closer at our base maze. It's made of squares, right? Some are walls and some are paths. Imagine shrinking our base maze, make it very, very small. Now we'll put a tiny copy of this maze inside each square of our original maze. Each of these tiny mazes is a sub-maze. They're like smaller versions of the original, nestled within its walls. We've put a tiny maze in each square, but we can do it again. Let's shrink our base maze even more. We can put a tiny copy of it inside each square of each sub-maze. This is called recursion. We repeat the same process, making smaller and smaller mazes inside mazes. The maze keeps growing, becoming more detailed and complex. The amazing thing is that we are using the same simple rule, putting a tiny maze in each square again and again, yet it creates something incredibly intricate. Fractal mazes are fascinating. They start with a simple idea, a basic maze, but by using recursion, they become incredibly complex. It's like a universe in a grain of sand. As we zoom in, we see the same patterns repeating at smaller and smaller scales. This is the beauty of fractals. They remind us that simple rules can create amazing complexity. These mazes are not just puzzles. They are a glimpse into the beauty of mathematics and the wonders of our universe. They show us that even in the smallest things there can be infinite wonder.